We are now on experiment number 2, Gauss Jordan method using MatLab. This activity will allow us to implement the Gauss Jordan method using MatLab, Freemat, Mathematica, or similar software. The objective is to construct a function script using MatLab, demonstrate our understanding involving systems of linear equations, implement Gauss Jordan method to find solutions to systems of linear equations using software. Materials that will be needed would be MatLab, Freemat, Mathematica, or similar software. Okay, so we are now starting our experiment. We are given a code here, a pseudocode, which can be found in numerical mathematics and computing, 6th edition, Ward Cheney, David Kincaid, on page 266. Okay. So on the first code, the first part here to this end, and this is for pivoting on our Gauss Jordan method, and then from this code to here, this code converts elements below our major diagonal to zeros, and then from this code to end here, this converts elements above the major diagonal to zeros, and then from this code to end, this converts the elements in the major diagonal of our matrix to ones. So the last line of the code is to display our results. So since I've been doing this quite a while now, I took the liberty on going to on typing our system of linear equation here, our matrix. So this one is our x sub 1, second one is our x sub 2, this one is x sub 3, this one is x sub 4. So always remember to put a semicolon here at the end, or the code will not work. And also we have to save it. Make a file name, just save it to your documents folder or on your Freemat. Okay, because if you're not going to do so, it will not work either, because the program would ask you to save it. So we are now going to execute our pseudocode. Just press execute current buffer. Okay, and we go back to our main program, the Freemat. So here it is. Just executed the Gauss Jordan method. So the source code here was saved. And this always remember to save. Okay, so it did the Gauss Jordan method correctly. So our answer on x sub 1 is negative 1.0947. Our x sub 2 is 0.1053. X sub 3 is negative 0.4421, and x sub 4 is 1.9158. Questions. Question 1. Suppose a zero-valued coefficient is placed in the element 1, row 1, column 1 of the matrix. How would that be corrected? The program will give you an error mismatch in dimension 2 for elements being concentrated along dimension 1, and you must place a non-zero element for it to work. Question 2. There are a lot of ways to implement the Gauss Jordan method, since the operations are not fixed for every matrix. Explain why you chose to implement it that way. What are the advantages and disadvantages of your program? So again, this is the first time that I've been using Freemat, and I based the program on the pseudocode that was given on the book, and through trial and error I made progress in creating this program. And the advantage of it is that I made it in a cascading manner, in which the steps of the pseudocode could easily be read and understood by the user. The advantage is that it might not work for everyone, because everyone thinks differently. So, question 3. What can you conclude from this activity? That MatLab or programs similar to it like Freemat can be used to create a pseudo programs to learn numerical methods. This concludes our experiment number 2. Thank you for watching the video.